Hey, this is Mr. James. In this video, we're going to be talking about some other angular relationships in circles. So if two lines intersect a circle, there are three places where they could intersect. They could intersect on the circle, they can intersect inside the circle, or they could intersect outside the circle, just like those three pictures show you. Now we've talked about a couple of cases where two lines intersect on the circle with an inscribed angle, or inside the circle with a central angle, but we haven't covered all the different cases. Before we start talking about all the different cases, let's do a quick recap of what we know so far. As you're doing this quick review, we're going to answer questions A, B, C, and D below. If you'd like, pause the video here and try questions A, B, C, and D first, then unpause the video to make sure you are right. Go ahead and pause now. Alright, here I've got a circle. It's a poorly drawn circle, but just bear with me. And here's the center of my circle. And we've talked about two kinds of angles in circles so far. If I have two lines that intersect at the center of a circle, we call this a central angle. We call this angle right here a central angle. And we know that the arc intercepted by the central angle is the same measure as the angle itself. So if this arc is 80 degrees, this angle is 80 degrees. And that gives you your answers for questions A and B. We've also talked about this kind of angle, when the angle is on the edge of the circle like that. That's called an inscribed angle. And what do you know about inscribed angles? Well, we know that if I have this intercepted arc right here, that this is double the length, double the measure of this inscribed angle right here. So if this arc was an 80-degree arc, this inscribed angle would be 40 degrees. So it's half. And that gives you your answers to questions C and D. However, we haven't talked about what happens if maybe two lines intersect in a circle but not in the center. We haven't talked about what happens if we've got a tangent line and another line that intersects it. We haven't talked about if we've got two lines that intersect outside of a circle. And that's what we're going to talk about for the rest of this video. Alright, and here are the answers to A, B, C, and D that you're hopefully writing down as we were doing the explanation. If you didn't write them down, here's your chance. Pause the video here before we keep going. Now that we've talked about central angles and inscribed angles, there's three other kinds of cases or angles that we're going to work with in this video. The first one is this. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. That's a little confusing, so let me explain what that means. If you've got an angle that has its vertex on the circle, and it's formed with a tangent line right there, and a chord right there, we are saying that this angle right here is half the size of this arc right here, and that this angle right here is half the size of this arc right here. Let's actually throw some numbers there and see if we can try a problem. Let's say, I'll just make this up, arc BA is, I don't know, let's do 100 degrees. Then angle 1 would be half of that, or 50 degrees. And if arc BA was 100 degrees, then arc BCA, it's a major arc right there, BCA would be, let's see, 100 minus 360 would be 260. So this would be 260. And again, our rule says that this angle will be half of 260, or 130 degrees. And that makes sense because now this adds up to 180. Now, these right here are formulas that you could use to solve these problems, although you might not really need a formula. All you need to do is remember that the angle is half of the arc, just like it was with inscribed angles. Pause the video here, go ahead and try A, B, C, and D below. If you can't do C, it's a little tricky, at least try and do D after you try A and B. So go ahead and pause the video, unpause it when you feel ready. Right, here we go. Line M is tangent to the circle. Find the measure of the red angular arc. Alright, so in A, we've got this arc is 150 degrees, and we need to find this angle right here. Well, that angle will be half of the arc. So 1/2 times 150, or 150 divided by 2, equals 75 degrees. So that is 75 degrees right there. B. All right, well, this angle right here is 130 degrees, and it's formed by a tangent line and a chord. So to get to the arc, we're going to have to double it. So 2 times 130 gives us 260 degrees. And so this arc PSR is 260 degrees. C is a more algebraic problem, which might be confusing for some people, but actually it's not too bad. In the diagram below, line BC is tangent to the circle. Find the measure of angle CBD. Now, with any algebra problem, we need to set up an equation first. And to do that, we need to know the relationship between all of the labeled sides. So what is the relationship between this angle and this arc? Well, I need to double this angle to get to this arc. That's exactly what I'll do. I need two 5x's to equal the arc, 9x plus 20, which is 10x equals 9x plus 20. If you subtract 9 from both sides, you get x equals 20. Now they wanted me to find the measure of angle CBD, so I've got to plug that back in right to here. So 5 times 20 gets me, let's see, 100 degrees. So this is 100 degrees. D, how is this theorem similar to the inscribed angle theorem? Well, they're actually pretty similar. In both of them, I've got an angle that comes in, has its vertex on the edge of the circle, and goes back out. The only difference is that in the inscribed angle theorem, both of the sides of the angle are chords, but in this new theorem, one side is a chord and the other side is a tangent line. But that doesn't matter. In both cases, I've got the vertex on the edge of the circle, and in both cases, the angle is half the size of this intercepted arc. So the angle is 1/2 times the arc. Now we've talked about what if two lines intersect on the edge of a circle, but we haven't really talked about what happens if two lines intersect somewhere in the middle, in the interior of a circle. So here it is. If two chords intersect in the interior of a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. What does that mean? Well, let me give you an example. Over in this picture over here, this angle right here, angle 1, and this other angle over here are equal to, if I took this arc DC, this arc AB, added them together, and divided by 2. Let's put some real numbers to that. Let's say that arc AB was 20 degrees. Let's say that arc DC was 10 degrees. Then what would angle 1 be? Well, I would do 20 degrees plus 10 degrees and divide that by 2. Okay? I'm kind of taking an average here. So 20 plus 10 is 30, divide by 2 is 15. So angle 1 is 15 degrees. 15 degrees. And this other angle here, since it's a vertical angle, is also 15 degrees. If that makes sense to you, go ahead and try A and B below and pause the video. When you're all set, go ahead and unpause it to see how I would do. Alright, hopefully you've had a shot at this. Here we go. A, find the value of x. Well, let's see. This arc right here is 174 degrees. This arc right here is 106 degrees. And so to find this, the rule is add them together and divide by 2. So I'll do 106 plus 174 and divide that by 2. Okay, so let's see, add them together, divide them by 2, and I get 140 degrees. So it turns out that x is 140 degrees. 140 degrees over here as well, because it's a vertical angle. They didn't ask for it, but there it is. For B, are you able to find the measure of angle QXP? Let's see, QXP, can we find the measure of that? Well, we could. We know that these two angles are going to be supplementary. So 140, take away 180, you're left with 40 degrees. So the answer is yes. Yes to the first one. Are you able to find the measure of arc QP? Let's see, QP. Can I figure out what this is? A lot of you might be tempted to say that QP is 40 degrees because the central angle is 40 degrees. But it's not. This is not a central angle because they do not intersect at the center. So I'm not sure what QP is, but it's definitely not 40 degrees. So let's write this down. We can't find what QP is because X is not at the center of the circle. So we can't use central angles here. If it was the center, we could use central angles and we'd be much better off. But we're not, so we're left wondering what QP is. So far we've talked about what happens if two lines intersect on the edge of a circle, or what happens if two lines intersect inside of a circle. Now we're going to talk about what happens if two lines intersect on the outside of a circle. Here we go. If a tangent and a secant, two tangents or two secants intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. Here's what that means. To find angle 1, I would take arc AC and arc BC, subtract them, and then divide by 2. Let's put some numbers there so we can see that a little clearer. Let's say AC is, I don't know, 80 degrees. Let's say arc BC is 100 degrees. To find the measure of angle 1, I would take 100 degrees, subtract 80 degrees, and divide that by 2. Just so happens that 80 minus 100 is 20. Divided by 2, we get 10. So angle 1 is 10 degrees. I've just put down some numbers for the second and the third diagram here. So if you can copy down those numbers, 100, 50, and 100, and then pause the video and try and find the measure of angles 2 and 3. When you think you're all set, unpause the video. Here we go. To find the measure of angle 2, well, it's a little tricky. I give you that this arc right here is 100, but you'll need to figure out what this arc is as well. It's not too bad, though. We know that the entire circle will add up to 360 degrees, and since 100 is just part of the circle, the other part of the circle is going to be 360 minus 100, or 260 degrees. After that, it's just a matter of using the rule. 260 minus 100 divided by 2 gets us 80 degrees. So angle 2 is 80 degrees. For 3, just using the rule again, 100 degrees minus 50 degrees divided by 2 gives us 25 degrees. So angle 3 is 25 degrees. At this point, go on and try A and B below. They're a little more challenging, but I think you can do it. Unpause the video when you're ready. Alright, let's take a look at A. For A, it's a little tricky because they give us this angle here and they want us to find the measure of that arc. Well, let's start by just writing down what we know. We know that angle H is going to have to equal arc GDE minus arc GF divided by 2. Now, if we plug the numbers in, we get 72 degrees equals 200 degrees minus x over 2. Now, to solve this equation, we have to get that divided by 2 away from that side of our equation. How do we do that? Well, remember inverse operations. The opposite of divided by 2 is multiplying by 2. So I'll multiply both sides by 2. Okay. The divide by 2 and times 2 will cancel out. I'll be left with 144 equals 200 minus x. At that point, it's not too much more work to solve and find that x equals 56 degrees. On the other hand, problem B isn't too bad. It's very similar to the second problem we did right up here, so I'll just put the work up. Alright, and here's the work. X equals 88. Pause it if you'd like to look at it. Before we go, here's a quick review that you can write down on the bottom of your paper. If two lines intersect on the edge of a circle, then this angle is equal to this included arc divided by 2. If two lines intersect in the interior of a circle, then this angle is equal to the two arcs added together and divided by 2. And if two lines intersect on the exterior of a circle, then this angle is equal to the two included arcs subtracted and divided by 2. Good luck!